Hi, Assalamualaikum. Good day, Doctor. Today, our group will present about our assignment to recyclable material classification by using convolutional neural network (CNN). So, our group member is consisted of Muhammad Nashrul Syahmi bin Saifullah, Muhammad Afiq bin Mustappa Kamal, and me myself Nurul Zainani bin Zaini. So, there are many solid waste remain stranded by the sea nowadays, like PET bottles and aluminium cans. So it is our responsibility to reduce the pollution and save our ocean. Therefore, the aim for this project is to analyze the visual image of PET water or PET bottle and aluminium can detection based on convolutional neural network (CNN). And it also to demonstrate visual image of PET bottle and aluminium can detection based on CNN. So the methodology for this assignment is a convolutional neural network is a unique type of multi-layer neural networks intended to immediately identify visual patterns from pictures with minimal pre-processing. Convolutional networks works by moving small filters across the input image, which is the filters are reused for recognizing patterns throughout the entire input image. Convolutional networks is faster to train because it is much powerful than fully connected networks with the same number of variables. So we use the Google Lab by pattern language to solve the problem given because it is free online cloud-based Jupyter notebook environment and allow us to train our machine learning and deep learning models on CPUs and GPUs and TPUs. So the deep learning means that as the figure shown here, the figure shown the complete flow of convolutional neural network to process an input image and classifies the object based on values or filters. So for the layer 1 consists of input layer, and layer 2, layer 3, layer 4 and layer 5 consists of convolutional layer, and layer 6, layer 7 and layer 8 is a dense layer. So for the task 1 is to design the convolutional neural network models to train the data without overfitting or underfitting. The constructed models was trained by change the parameter to find the highest possibility performance, and we record its outcome, and we finally get an optimal model M1. Then 3 type of new image was loaded, and all the 3 pictures was fed to the model M1, and we had analyzed its outcome. So to train the data using CNN, we must first connect with Google Drive, and then we feed the dataset directory in the Google Drive. So we create train and validation data directory like this. We also have to copy and paste the path. Like say for train directory, we use the datasets that from the train folder, and can and PET train directory also comes from the train folder for can and PET directory, and same as the validation directory. We also use the same step to create and train the validation directory, and we use import TensorFlow from TensorFlow Keras.optimizer, from Preprocessing image, and Keras application import BGG16. So we construct the CNN model. This is the coding that we use. So for the convolutional layer 2D, we use the filters value of 32, and then 33, and activation value, and input shape we used 150 times 150. And then for the max pooling 2D to 2, and for the convolutional layer 2, we use the value of 64, the value of 64 and 33. And max pooling 2D for the convolutional layer 3, the filters, the value of filters is 12833, and the max pooling to 2, and then we flatten. And then the dense value we use 512 and 1. So to form the architecture, we must run the coding like this. And then this is our model architecture. So as you can see here, this is our output shape that we get. And then we get the trainable parameters 19034177 and 0 value for non-trainable parameters. Okay, so step 5, we classify the image labeling. So from class preprocessing image import image generator, we generate the batch of tensor image data. We rescale it equal to, we rescale it by divide 1 and 255. We must rescale because we want to have a normalized value 0 to 1. So the rotation range we use is equal to 40, with shift range is equal to 0.2, height shift range equal to 0.2, shear range equal to 0.2, zoom range equal to 0.2, horizontal flip is true because we want the horizontal flip. And then the validation data gen, we define it as image data generator rescale as 1 divided by 255. Okay. From the train generator, we use the target size of 150 times 150 and batch size 20. Class mode is categorical, and validation generator, we use target size 150 times 150 and batch size 20. Class mode is categorical. And then we found the 466 image belonging to 2 classes and 210 image belonging to 2 classes. And this is our code for import plot graph. So we plot we import image. So we plot the image with their own classes like this, and then we pre-process the input. We pre-process the input data batch size for training and validation. So this is this is the coding, and all image will be scaled by 1/255, and then and then as it starts training process, the step 8 start training process for a few times to get the highest validation accuracy, and training accuracy will also need to be considered. We use the epoch is equal to 40, and step for epoch is length train generator, and validation step is length train generator. This is our output that we get. Okay, then we plot the output value of the validation and training onto graph, and then this is the graph that we get for a clear visualize. So for the training and validation accuracy, we get the highest value, the highest training accuracy, 100% of training accuracy. So when we running the program for the first time, it shows that the increasing percentage in training accuracy along with percentage in validation accuracy. Then it's proof that it needs to train for a few times to validate 2 class of image. So the final training appeared to give high percentage, and validation accuracy and starting validation accuracy also high. And then the training and validation loss, as we can see here, it is low. It is low. Most of the effort is zero value. Okay. Now fit first image to M1. The pad and can is put side by side, and then we display image in the coding, and first image is tested. So the output state that this image is 100% can and 100% pad, and fit second image to M1. The setup is the bottle is 15 cm behind the can. So we key into the coding to display the image, and then the second image tested. The output state that this image is 100% can and 100% pad. And then we fit the third image to M1. The can is behind 50 cm behind the pad, and then we display the image into the coding. Hence the third image tested, the output state that this image is 100% can and 100% pad.
Today I will present about our project in part of task 2. Okay, for the task 2, we need to repeat the training process and find the optimal model. BGG and Inception has been chosen as the pre-trained model to train using the given data and compare its outcome from result obtained in task 1. BGG16 is one of the convolutional neural network architecture that can perform an innovative object recognition model. In ImageNet, the training model have achieved around 92.7% test accuracy, which has a dataset of over 14 million images that belongs to 1000 classes. It also can perform many tasks and dataset and can support up to 19 layers. Next is Inception network. It is also one of the convolutional neural network that can allow for more deeper network and more computation efficiency that can be achieved through reduction of dimensionality with stack of 1x1 convolution. For the first part of VGG, we need to do some code for the pre-trained model with VGG16. Every convolutional layer output can be seen in output shape for their dimension and also their parameter sum. For the first picture is the construct the pre-trained model with VGG. You can see here for the first image on the left, and then for the you can see the convolutional output layer on the side, and this we can see the total parameters and trainable parameters, also the non-trainable parameters. For the second step is that this step needed to go through after hidden layer at step 6 for final output layer, turning the data into one dimension after two dimensions. This is the code for the step 2, which will be used after step 6. For the third part, we can start the training process for a few times to get highest validation accuracy. Training accuracy also needs to be considered. This is the code for the part. You can see the step loss, validation loss, and accuracy in this picture. For step 5, we can plot the graph. As we can see here, in both graphs, we can see that training and validation accuracy and the training loss and validation loss are almost same. Only in few parts or in the earlier we can see that the loss is higher and the accuracy is very lower. And after that it remains constant, which is shows that it can be trained so that it can have more accuracy and less loss. Okay, for the next part is part 6, which is testing with all the 3 pictures. As we can see from the result in the slide, you can see that all the 3 images got a perfect score, which is 100%. It shows that this VGG CNN model can train and get a better accuracy.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahmi bin Saifullah. Now we continue for the second pre-trained model that I used for the STARS 2 for the vision assignment 2. It is Inception. So Inception, first we know that before we start the Inception process, we need to connect the Google Drive by use the first coding that I use for the VGG and also the send without VGG. And then same process for the second process, I used to connect the folder that I put the folder train and also validation folder inside that, this dataset. And then this is the library that I need to import. So here is the configuration for the insertion. So just import the from TensorFlow.compact.v1, just import config proto. And then from TensorFlow.compact.v1, import interactive session. And then just configure. This one is to import the important libraries like as TF here, TensorFlow, and then AmRes prop. In section V3, input lambda dense and flatten. This one is for the process insertion, which is I need to input lambda and flatten and then also dense. Next, here is also the other important libraries, like this is categorical to categorize, and then it's the preprocess input for the insertion, and etc. Alright. Next, this is the insertion process. So the first code here up here is for to the insertion insertion training for each layer, and then add equal flatten mean that the flatten the layers, and then it's a prediction dense, and then we will dense all the layers. For the code model summary, that we will find out that all the summary will appear in the Google Colab. Alright, this is the summary. So actually it has a long summary here, but I snap for the at the last summary. From the summary, we know that each of the layer have been max pooling and been processed by inception, and then after that it will flatten and then dense. And here is the total output. Total parameter here is 21,821,217. So trainable parameter only 18,433, and non-trainable is etc. from the trainable parameters, which is 21,802,784. So this one is to pre-process the input data. So here I use the same base size for the train generator and validation generator, same like the VGG and JN without VGG. So target size also say 150, 150. At the same time, I also here is to rescale the train data gen and also rescale the test data gen here. So this is the output that have been print for the print database shape and print labels base shape. So found out that 466 images belonging to 2 classes, and found that 210 images belonging to 2 classes too. And database shape is 8 is with base size, and 150 is the target size, and 3. So the label base shape is 8 too. So there is have here 8 have the 2 column here. So we'll show you later. Here is the pre-processing. I mean that it is the training process. So training process here, for the epoch, I use the same value here. It is 40 40 epochs here I use, and then step per epoch just learn to train generator, and validation step also learn to validation generator. So this is the output value from the training process. So we find out that I just snap here to the near to 40 push. Alright, so let's see here the accuracy have been perfect, which is 1.00, it is 100%, and then also validation accuracy is 1.000. It means that the accuracy and validation accuracy at the steady state, which is stable, and this is the graph. So the graph is beautiful because it not decrease lower than expected. It decreased only until 0.99, and then it decrease, and also and lastly it will rapidly increase until 1.00 and remain constant at steady state here. And the training and validation loss we see here, why the loss is decreased, the loss decrease, and then the training will increase, and then if the loss is increased, the validation accuracy will decrease. So it means that here the validation loss and training loss at the lowest point here, so it means it is perfect. So here I need to feed three types of pictures, which is the first picture is the PET bottle put side by side with the can, and the second picture is the PET bottle is back put behind from the can 50 centimeter, and the last the last image is just put the can behind the pad around 50 centimeter. So here is the result. So the first image, I try to run to this model that be pre-trained from the Inception, and then I found out that this image already detected 100% can and 100% pad. It means that it detect that in the image has can and also have pad. Okay, same goes like this and like this. So the second image and third image also have 100. No. The second image has 0% and 0% pad. It means that the second image, it cannot detect the image of can, and it cannot detect the image of pad. So the third images, it detect 95.66% can and 95.66% pad. It means that it almost detect the can and pad, but it seems that not almost, but it's perfect because it is very near to 100%. So as a conclusion, we managed to fulfill the task 1, which use CNN model to train the data without overfitting or underfitting. It means that the graph is not underfitting or overfitting, it's just nice, and then able to maintain at the constant in the stable state. We also managed to analyze the performance and record the outcome. We managed the analyze the performance by using the Google Colab and record the outcome step by step. And then to achieve the task that has been given, we use Google Colab and Spider Python. I actually use Google Colab, and I also use Spider Python before, but I think the Google Colab is more easier, so that I use Google Colab. In this project, we learn about new software that can also increase our knowledge. Based on training result using Google Colab, the model need to be trained few times so that it can validate two images. Model need to be trained few times. Alright, actually not can validate two images. In the Google Colab, the model need to be trained few times, and then so that it will go to train all the images, even though the images have been classified into two classes or three classes or more. You need to be trained more until you get the stable graph or the validation accuracy achieve 100% or near to 100%. Alright, next I will show you the demonstration that I been made for this assignment. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nashrul bin Saifullah. Now I present to you for assignment 2 for revision. Subject, firstly, I need to train by using CNN, and then I need to test. I need to fit 3 type of pictures. First picture is put the bottle side by side with the can, and then the second image is I need to put the bottle backward around 50 centimeter from can, and then the third image is I need to put the can at the behind 50 centimeter behind the bottle. Alright, so let's continue for the demonstration. So firstly, I need to run this to connect the Google Drive into my Google Colab, and then I need to import the dataset directory based on the link that I place all the dataset for this training. Right. Next here, I will create train and validation data directory. So I place here the link for the train and this validation directory. And then this is cat and pet stored in the train folder, and this is cat and pet stored in the validation. So here we appear cat train length, which is 156, and pet train length is 310. Can val length is 77, pet val length is 133. Alright, let's continue. This one is to import the important libraries, which is TensorFlow, TF, RMS prop, behavior generator, and this is to construct the CNN model. Right. So to construct the CNN model, we will here is the every layer that to match pooling, and then this is the flatten and the dense. Right. So this is the output. So for this layer, we show you the parameter for 32, 64, and also 128. This is the flatten and this is the dense. Okay, so total parameter is 90,034,177. So trainable parameter all is trained, but and non-trainable parameter is 0. So here is I want to classify into 2 classes, which is pet and can. So and then I want to plot the image and labeling, which one is pet, which one is can. So here I import the library for image data generator, and here I rescale in the train datagen and val datagen. Inside that train generator and val generator, I put base size around 20 for each, and then target size 150, 150. So that it will clear to see. So we found that 466 images belong to 2 classes and 210 images belong to 2 classes. So here I import the matplotlib pilot SPLT to ensure that the image can appear inside the Google Colab by using the matplotlib. And then this is what we will classify into 2 names with cat and pet. So here we here is the code to ensure that the image can be appear like this and labeled as like this. Pet. So this is pet, this is can, pet, and can. Alright, so this is, let's continue to the important part. This is the pre-process the input data. So in pre-process input data, I put the base size around 8 for the train generator and also valuation generator. And then I also train datagen and test datagen. We scale them into 1 point per 225. Alright, so and then this is class mode in binary for the CNN pre-trained model, and then I will appear for the database shape and labels base shape. So I found this is the same like above. I found 2 classes, and then this is database shape 8, 150, 150 here, and 3 label base shape 8. Okay, so this is the long process. Here I need to model and train. So I put a push around 40. So it means that I train in 40 times. We step per push length for train generator, and then validation step length validation generator. So let's see here. So here, epoch start from 1/40 until 40/40. So per epoch here, we see that step per epoch is land train generator. So here is 59/59. It means that from 1 until 59 it will train and then continue to the next epoch. Usually at the first try train the model, it not show very stable graph, but it will remain a stable at specific epoch, and then it will remain steady state, but not very beautiful graph. You need to run more than one or more than two times to ensure that the graph in good. Here is the accuracy and here is the validation accuracy. So it shows validation accuracy did not achieve 1.0 yet. Almost done. Now we are at 37. Okay, done. So next step is to plot the graph outcome. Here is the input matplotlib so that we can figure inside in the Google Colab by using matplotlib. And then here is the what we define accuracy, val accuracy, loss and val loss. And then here is the first graph and this is the second graph. So first graph is training and validation accuracy, and the second graph is training loss versus validation loss. So let's see the graph. So here is the graph. So the graph before I get is more beautiful because I try to train again and again. So but this graph also get the stable state for the variation accuracy, and also for the variation loss is lower. Alright, so next we need to fit three images. So first image that I told you just now, which is put side by side. So this is the code to upload the image so that I can show you the image that I need to train and I need to test. So this is the pack and the can put side by side. So firstly, I need to import class, and from class I need to import to categorical so I can categorize which one is pet and which one is can. So inside this, I will make a prediction and then make a how many percent can detect can and can detect pet. So previous I get 100% can, 100% pet. So let's see. Alright, so for the first image I get 100% can and 100% pet. So it means that success. And then this is the second image. So second image is the bottle is at the behind can 50 centimeter. So I run here. So even though the bottle is at the behind 50 centimeter from the can, but it also can detect the pet and also 100% can detect can. So it is good. So for the third picture, this is the third picture, which is the can is at behind 50 centimeter from the bottle, from the pad, and then let's try it run whether you can detect the bottle or and can. Right, let's see that the result also same, even though the can is behind the bottle 50 centimeter. So the image also 100% can and 100% pad. Alright, that's all from me for the CNN. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nashrul bin Saifullah. Now I continue for the task 2 for the assignment 2 vision. So this one is with VGG. So same step. Firstly, we need to connect the Google Drive so that we can feed the data set directory from the Google Drive. So just copy the link path from the Google Drive, which one we want to export to the Google Colab, right? Alright. And then here is the create train and validation data directory. So I just copy the path from train while and then cat and pad from the train and cat and pad from the validation. Alright. And then I just print out here the can train link, pad train link, just same like the CNN. So here is also same libraries, important library that I import for CNN. Just import it, and then this is one is the important part is I construct pre-trained model with the VGG. So here we see the input layer, and then this is the layer that have been max pooling. There are around 5 layer, and there is a total parameter, but the total parameter not be trained yet. So here is the training session. So I train it to flatten and dense so that it can be trained for the VGG. So here is the flatten, dense, 2 and S3. So it's the trainable parameter here. Alright, next what is I do is need to pre-process the input data. So same like the CNN, I just put the target size 150, 150, and then base size is 8 for the train generator and also validation generator. And then I rescale train data gen and test data gen to 1.255, and then I print out the classes that around 460 images belong to classes and 210 images belong to 2 classes. And here I print out the database where 8 is the base size, and then 150, 150 is target size, and 3. And that is the label base shape. Okay, so here is the important part that I need to start the training process. And then the epoch is 40, same like CNN, so that I can compare for the VGG and CNN. So it may take time because it have 40 epochs. Step per epoch depend on the train generator, and validation step also depend on the validation generator. So you see that 55 over 55. Okay. Right, 4 more equals left. 3 more. I hope it gives the best result for the graph. Okay. Done. Alright, next I need to plot the outcome where I need to plot the graph. So just use import matplotlib to plot the graph. And then this is same like before. I define SEC as accuracy, while SEC validation accuracy, loss. And then while loss from this output to be the input for the graph. Okay, so this is the first graph, training and validation accuracy, and the second graph, training versus validation loss. So here is the output for the output graph for the VGG. So it seems very, very nice because it's not underfit or overfit. So it decreased at here, at the point here, but suddenly it rise up again and then continue steady state, stable like that. And also the loss is very low. So let's try to fit the first image. This is the first image, bottle and the can put side by side. Alright, so the image is 100% can and 100% pet, so success. And then the second image, the pet is behind from the can around 15 centimeter. And then let's see. Alright, so also success, even though the bottle is behind. So 100% for the can, 100% for the pet. This is the last image. Is the can is 15 centimeter behind the bottle or pet. So let's see how's the result. So the result also same as success, even though the can is behind, but it can detect the can, 100% can and 100% pet. So that's all for me for the VGG. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahmi Saifullah. Now I present to you for the second type of pre-trained model that I use in Inception for the task 2 assignment 2 vision. And yeah, as usual, you need to connect the Google Drive, feed the data set directory, and then this is create train validation. Right, this is the TensorFlow config proto and interactive session. So I put the library and configure up, and then this is the import another important libraries. After that, I resize the images from the train and validation folder. Right, here is the inception progress for the flatten for the layers, each layer, and then this is the dense, and this is the model summary of the structure model. Okay, so it's quite long here, so I will just summarize what is in here. So at the top here, you see the input layer. So there are many layers here have been processing by the inception. All right. So next, lastly, it will flatten and dense all the layer. So here is the training parameter and non-training parameter from the total parameter. So next, what I need to do, pre-process the input data. So here is the code for the compile metric accuracy. Now I use the metric accuracy. And then this part is I need to rescale again, trade and test for 1.255, and then put the best size 8 and target size 150, 150, same as before for the VGG and CNN. Train generator and validation generator have the same target size and base size. Class mode we put a categorical. Alright, so this is the images of 160 images belonging to classes, 210 images belonging to two classes also. Database same 8 for the base size, 150 is for the target size. So here is now I train the process. It take few time because my push same as the VG and ZN, which is 40 push. From now it seems nice because the accuracy and accuracy 1.0 since here since the fourth push. Alright. Four left to go. Two left. Almost done. Okay. So next, here is the plot outcome. So just use a matplotlib to plot. There I made two graph. See the graph is very nice. At the first place, it decreasing until under 0.88, but suddenly it rapidly increase and then remain constant at the steady state. Okay, let's try for the first image. This is the first image that we fed. I will feed into this optimal model. So let's import crush into categorical, and then let's see how many percent we get. Yeah, wow, 100% can and 100% pet. Nice. This one is second image. Is the bottle is 50 centimeter behind the can, and then let's see if they can detect the bottle and can. Bottle can okay, nice. 100% can and 100% pet. So this one is the can is 15 centimeter behind the pet. Let's see. Nice, so perfect. 100% can and 100% pet.